So branch with unsigned comparison, we have already talked about the conditional branches using BEQ, BNE, BLT, BGE. We are going to discuss a little bit about BLTU and BGEU. But before we talk about this, again, it will consider RS1 and RS2 both as unsigned numbers. Although they may be a signed number, but while making a comparison, it will treat both the numbers as unsigned. Okay? So if we have this condition, let's say we have S1 value 9, okay, and if we have to check T0 less than 0, so there are two conditions that we are checking here, whether T0 is less than 0 and T0 is greater and equal to S1. So these are the two conditions that we are checking, and we are also performing altogether one operation. These two pipes corresponds to OR in high level language. Okay, so once this condition satisfied, go to this label. Okay, now how does OR operation work? When we have two inputs, how does it work? Yep. If any of the value is true, then the output is true. Okay, so if first condition is true, then it does not need to check the other condition. Okay, the output will always be true. Okay, so first condition, if first condition satisfy, then it should directly go to label, this particular label. Okay, if the first condition is false, then it has to check other condition also. It may be true or it may be false, the second condition. Okay, then once the condition satisfied, then it will jump, otherwise it will consider it as a false condition. Okay, so when you translate this into RISC-V code, how would you write this? Is like this: BLT T0 is less than X0. If this condition satisfy, branch if less than, if T0 is less than X0, then do not need to check other condition. Directly jump to this label. If this condition does not satisfy, it means it has to check other condition also. Because if this condition does not satisfy, it will not take the branch, it will proceed ahead with the execution of next instruction. Agreed? So this is the implementation of this condition using BLT and BGE. Specifically for this condition, we can actually implement this with a single instruction when we use BGEU. Can anyone elaborate on how does this work? If T0, so first of all, see the condition S1 here is 9. Okay, so assume that if T0 is greater than 9, for example, let's say 10, then this condition would definitely work. BGEU, T0 is greater than S1, then it will jump to L error. Okay, if T0 is less than 0 for this one, would this still hold true? So let me put this up. This when T0 was, suppose it's 10, right? Then the condition which we were checking, BGEU T0 S0 and jump to L error. So when T0 is 10, this condition will satisfy. Let's say if T0 is negative number, let's say -1. How do you write -1? We write, this is simply -1 value, right? But this condition, this instruction is treating T0 as unsigned number. So this condition will still hold true because T0 would be treated as bigger than, way bigger than S0. So in that condition, it will still jump to L underscore error. Okay? Understand? So for this particular case, T0 is less than 0 can still be checked with BGEU, and T0 is greater than equal to S1, again S0 or S1, whatever. Okay, so you need to identify if you can avoid large number of instructions as much as possible. You need to write an optimized program. Okay? Yep.
So this only works because we know what T0 is. We know that it's...
Yeah, so actually compiler is supposed to be identifying this condition. It should be smart enough to translate this high level statement into one RISC-V instruction instead of writing two instructions. Okay?